Okay, so we'll go ahead and get started with our webinar. So again, this is the Modular Circuits Demonstrations webinar. And what we're going to be doing today, it's a very short webinar. We got 30 minutes and we have a very simple agenda. I'm going to show you how you can use modular circuits to just do some really basic circuits, starting with a very simple circuit where we'll just light up a light bulb and then just gradually build on that circuit so we can have series and parallel circuits, and then also show how you can take measurements with those circuits using voltage and current sensors. To give you a short introduction of our modular circuits kit, which I have right here, this is a wonderful kit that comes with many different modules. We're not going to go through all the modules today, but you'll see some of them. It's wonderful to build very simple circuits. It's a great introduction to circuits because you can see all of the circuit diagrams on each of the modules, and it's very easy for students to read and understand the circuits and what's going on. It's nice not to have any tangled wires involved because that's often troublesome for students, where they're trying to build a circuit and a circuit doesn't work. It's hard to troubleshoot when you have all these wires going all over the place. It's really hard for the teachers to try to troubleshoot what's going on with a circuit when it's not working with all those wires. So that's one thing I really love about modular circuits. And also, we have some special modules that have built-in sensors that can allow you to take measurements. So we're going to keep this very simple to start off with. We're just going to build a very basic circuit. This comes from experiments that we have from our essential physics curriculum, and those are available for free. The student handouts are available for free on the PASCO website, and I'll provide you with a link to that at the end of the webinar. So the first goal is to just build a very simple circuit to light up a bulb. So in this case here, we only have 6 modules that we need to do this. There's many different ways you could present this to students. You could just present the circuit diagram as you see on the slide on the far right and just say, okay, follow that. Try to find those same diagrams on the modules that you're given and try to build that circuit. Or you could show them a picture of that too, if they need some more scaffolding. But or you just give them the modules and see what they can come up with. That's what's great about this, is that there's many different ways that you can approach this. So I'm going to start by just building this very simple circuit. So what I'm going to do is I'm going to get my battery module, and I'm going to pull that other one out. And let's see, I also need a light bulb. Here's my light bulb. And I'm going to need 1, 2, 3, 4 corners. Okay, so I'm going to start off with that, and I'm going to change my view so you can see this a little bit more easily. Okay, so there's all of my modules. So, it's like puzzle pieces. They interlock with each other like this. And there we go. But hold on a second, my light bulb's not lighting up. What's going on here? Well, there's a little bit of an issue. So even though each of these modules are connected physically, they're not connected electrically, because in between each of the modules, there is just plastic. It's an insulator. You need to have some sort of a metal to connect each of those modules. And what we use for that are these jumpers that connect each of the modules. So in order to get this to work, you have to make sure that it's not only physically connected, but it is also electrically connected. So I'm going to add in those jumpers. And there we go. Not sure how well you could see that on the camera, but let me try a different view there. There's the bulb lit up. Okay, very easy thing for students to start off with. Gives them some confidence. It's nice to have a good early success. But we can do a little bit more with this. Okay, so you could ask the students, what happens if you remove a jumper? What happens to the bulb? Well, the bulb goes out because you no longer have an electrical connection. What if we reverse the battery module? Instead of having, in this case, I'm not sure how it works on the screen for you, but let's see, at least it's on my left. Positive is on my left. What if we had positive on my right? So I'm going to take the battery module out, flip it upside down, replace the jumpers. Doesn't seem to make a difference. So you can have the battery either way. And students could try to, flip the bulb too, try other things out. Um, Now, of course, there is a type of light where this wouldn't work, which would be an LED. We do have LED modules as part of a LED module as part of the kit. So that's a nice extension for, a much later lesson. Okay, now that we got our first basic circuit, what can we do next? So let's add a switch. So I'm going to take those out. And let me find my switch module. So there's a switch. And I'll just put that in here. I'm also going to need another wire to hook those two modules together. Okay, switch is currently open, but if I close the switch to make a closed circuit, that lights up the light bulb. So now you can start introducing some vocabulary about closed circuits. Well, what's the other vocabulary word? Well, we have open circuits. I can open the circuit by opening the switch. However, is that the only way you can create an open circuit? What other ways could you do that in here? That would be a great question to pose to students. And I'm sure many students could come up with some very clever ways. Of course, one way you can take out a jumper. I guess some students might say you could take out the bulb completely, take out the battery, take out an entire module. Let's take it one step further. Let's add a second battery to our circuit. Okay. So I'm going to add a second battery. I'm going to need another wire module here. Then need to make sure I get all these connected. Okay, so when I add a second battery, let's see what happens to the brightness of the bulb. Not sure how well it shows up on camera, but at least in my perspective, on my eyes, I'm seeing a brighter bulb this time. So now students can start thinking about, okay, so adding a second battery makes a bulb brighter. What is it about those batteries that are making the bulb get brighter? Now here's another question. What would happen to the brightness if you added a second bulb to the circuit? Now, at this point, I mean, I like to pose to the students, well, what exactly does it mean to add a second bulb? Is there more than one way where we can add a second bulb? So this is where we'll start talking about series and parallel circuits. So first, I'm going to go ahead and add a bulb in series. So that's very easy to do here, looking at our diagram. So adding a bulb in series, I'm just going to go ahead and remove the wire module. And again, I'm going to use the bulb as my measuring instrument. So what happens to the brightness of the bulb, the original bulb, when I add a second bulb in series? Okay, and in this case here, the bulb still lights up. it looks like it's a little dimmer, kind of similar to when we only had one bulb and one battery. What if I unscrew one of the bulbs? What would happen in the circuit? So if I unscrew that one, oh, the other one goes out. If I unscrew this one, the other bulb goes out. So I'm creating an open circuit here, which makes sense because if you look at the circuit diagram on the modules, there's really only one path for the electrons to go and for the current to flow. And if you take out the bulb, you're breaking that circuit and you're creating an open circuit. Now, this is not the only way we can add a second bulb. We can also add a second bulb in parallel. And this one is usually a little bit trickier for students to understand and also to wire, especially when you're dealing with alligator clip wires. But with modular circuits, it's a lot easier to make a parallel circuit, even though it's still a little complex. But for this, I am just going to go ahead and take this whole part out, put it up here. Now I'm going to need wires going this way and up to the top of the circuit. So I'm going to need some T-junctions. So I got one of those right there. And here's another one. I'm just going to insert that there and then do that. And I'm going to go ahead and take this bulb, place it there. And I'm going to need a couple of wire modules. So I'm going to get that one and get another one right there. And then just go ahead and put in all of my jumpers. And before I insert the, oh, one lit up. Oh, that's interesting. So we have one bulb lighting up, but not the other bulb. We notice that it's also brighter than we had previously, isn't it? So students might be, yeah, if they started this way, they might be thinking, okay, what's going on? Well, what's going to happen when I add my next jumper? Okay, the other bulb lights up too. And interestingly, it's the same brightness and it doesn't have any effect on the other bulb. I could also unscrew them. So that's interesting. Yeah, what's going on there? So again, makes it very easy for students to try to figure out, what's going on here because they could just follow the path. Okay, I get up to here. There's two ways that the current can flow. So I could go this direction, go through that bulb, return back to the battery, or go over here, go this direction, return back to the battery. But if I take this bulb out, it has no effect on that bulb because, yeah, I still have a clear path to return home. So, yeah, some of the questions that you could pose to the students, how does the bulb brightness compare to the series circuit? And then unscrewing the other bulb and seeing what happens. Now, the next step to take is for measuring voltage and current. So now that to measure voltage and current, this is where we're going to need our sensors. So we have two sensors that we can use to measure voltage and current. First, we have our wireless voltage sensor. Let's see if I can get a closer up view for you on this. There we go. So the voltage sensor comes with two wires for positive and negative. There we go. And it has two ranges. Actually, I need to update this slide, I just realized, because it's no longer 15 plus or minus 15 volts. It's actually plus or minus 30 volts. And what's really nice about this voltage sensor is that not only does it measure, do static measurements, but you can also measure changing measurements, which is great for RC circuits. And what's really nice about it is that you can sample up to 100,000 points per second. So quite useful. Now, the other sensor is our current sensor module. So you notice that this one actually is in the shape of one of the modules from modular circuits. And we did this very specifically because one thing that is very difficult for students is knowing how to connect a current, like a multimeter in a circuit to measure current. I had a lot of trouble with this when I was teaching. Um, my students would always try to connect the circuits the same way. They would connect the multimeter the same way for measuring voltage and measuring current, trying to connect it in parallel. And that would often end up with the multimeter either blowing a fuse or, if it was a very cheap multimeter, completely destroy the multimeter. So that's what's great about this, is that being a module, it forces the students to actually connect it in series. Now, we know that some students are very clever and they might figure out a way how to not connect it in series. So thankfully, we also have built-in overcurrent protection with this, and it will sound out an alarm if it detects too much current flowing through. So you know exactly which student group to head over. Now we need a way to measure the current and voltage. So for that, we're going to be using our SparkView software. And our SparkView software can, get displayed in graphs and digit displays. Really nice for analysis. And what's great about this is that it also works on all platforms. You can even run it in the Chrome browser. And I will provide you with a link to our online version of SparkView at the end of the webinar. So first, let's go ahead and measure the bulbs in series. We'll measure the voltage and the current across the bulbs and through the bulbs. So I'm going to go ahead and just take this one out right now. I'm just going to keep this simple. I'm not going to do it exactly how the diagram shows. But up to this point, we've been using the bulbs mainly as measurement devices. But bulbs aren't the greatest measurement device because, brightness is relative between people. One person might see brightness a little bit differently. I'm sure you're probably seeing the brightness quite differently through the camera versus what I'm seeing in person. So you want to make sure that you actually have good solid measurements to understand what's going on in the circuit. So let's go ahead and pull out the voltage and the current sensors, and I'm going to get out of this PowerPoint and move to SparkView. So I'm going to go ahead and connect each of these sensors to SparkView. So you can see I have my voltage sensor and my current sensor there. And for this, I think I'm going to use digits and graph. As you can see, we have both voltage and current on the screen right now in a digit display and a graph display. Now, before I do any measurements, I'm going to go ahead and zero out my measurements. I mean, they're pretty close to zero already, but it's always good practice just to zero them out before I start. And then I'm going to go ahead and connect my current sensor to the circuit. So I'm just going to start by putting it in this location right here. So very easy. In series, don't need to worry about that. And let's get some more room here for the voltage sensor so you can see that. Now here's your tangled wires, right? Thankfully, we're only dealing with 2 wires though. So this is where the jumpers come in handy as well, is that you can connect the voltage sensor directly to the jumpers, and you can connect to any jumper in the circuit. So let's see, let me get that in view for you there. Okay. And let's go ahead and start collecting some data. So right now, it's at 0, but if I go ahead and close the circuit, okay, so now I'm getting some voltage and current data. Now, some other things that I can try out is, okay, so let's see. I got 2.76 there, all right? And I'm going to go ahead and add a second bulb. So we have two bulbs in series because that's originally what we were planning to do here. And I forgot to add that second bulb. So let me go ahead and do that. It's going to be easier to compare two bulbs as opposed to one bulb. All right, let's try that again. Okay, go ahead and close my circuit there. Okay, so now we have 1.153 around, somewhere around there for the voltage and about 0.5057 amps, 57 milliamps. Let's go ahead and measure across the other bulb and make a comparison. This is where I like having the graph nearby because you can make a comparison between the two. They're not exactly the same, are they? Yeah, they're close, but not quite the same. And I'm just gonna actually I'm gonna stop this for a moment, and I'm gonna use some of our analysis tools here to take a look at the values. So yeah, here I have 1.151 in SparkView, and then the other one 1.659. So a question to pose to the students is, what do those two values represent? And they can try to measure voltage at other parts of the circuit. What other things can you measure the voltage of? Well, probably the batteries are a good one, right? What if we measure the voltage across both batteries? Okay, 2.8. That seems like that sums up those two values that we saw for the bulbs, doesn't it? What if we went across both bulbs? Okay, and we're getting pretty much an identical value there, which is what we would expect. What if we move the current sensor? Let's say instead of putting it here, I put it over on this side. Okay, so looking back at SparkView, yeah, those two values look pretty much the same for current, doesn't it? Yeah, so then students can just, if they want to measure other points along the circuit, yeah, it's pretty easy to do that because you just take out a module, replace it with the current sensor. All right, so that's series circuits. You could do the same thing with a parallel circuit. So if I, let's see, we got some time here. Let me just go ahead and do this real quickly. I'm going to go ahead and take that out. Let's take this one out. I'm going to go ahead and put in the T-junction. And let's put the bulb here. And go ahead and replace those jumpers. So what about this time when we're measuring the voltage across the bulbs? What do we expect to see? Well, we remember from the brightness that they were brighter and they had approximately the same brightness. Let's see how that translates to voltage and current. Okay, so I'm going to go ahead and start SparkView. So previously we had 0.57 amps. Oh, and I forgot to put in the current sensor. So let's do that. Let's see how many amps we get this time. 0.16. Quite a bit more current than we had last time. Let's see about the voltage across each of the bulbs. Wow, a lot more voltage too. Voltage that's very similar to the voltage of our two batteries. Let's check out what the other light bulb is showing. Yep, about the same. And if I put it across the batteries there, yeah, pretty much all the same. We got a approximate. I mean, yeah, it's a little bit different, but yeah, there's various resistances in the modules, but you wouldn't get to that at this point in the lesson. But yeah, we're seeing pretty much the same voltage there. And what about the current? What if I place that in a different location? What if I place that in line with the bulbs? So what happens to the current there? Oh, 0.087. And let's see, what if I do it for the other junction? And let's see, move that out of the way. Yeah, it's a little bit less current, but you know, it's kind of looking like if you took the first current measurement and the second current measurement, kind of adds up to the total one that we saw there. So students could do more analysis with that. We don't have time for that today. I just wanted to show just a quick demo of this, but you can use the analysis tool here to determine what to get more precise measurements, and then students can analyze the data to see how they sum up. Another great tool that you could add here is maybe you want to annotate what this represents. So this is the current for entire circuit, and you can annotate this and say like this is for bulb 1. So a lot of great things that you can do to have students analyze their data further. So we're just about out of time here. So to go over just some of the equipment that you saw today, this is, again, our modular circuit set. The modular circuit set includes 27 circuit modules. You also get the wireless voltage sensor and the wireless current module with the set. This is not the only set we have, however. If you go to pasco.com/circuits, as you see in that slide, that will show you all the different types of kits that we have for modular circuits. We also have a smaller kit called the basic kit. And if you want to build your own kit, you can also buy these modules individually. And you'll also see that we have a whole bunch of other modules that you can also add on to your kit if you like. SparkView software, you can get that at sparkview.pasco.com. It is free. This will give you a way to try it out if you like. And for most devices, you might even see some built-in sensors that you can try out SparkView, even if you don't have one of the PASCO sensors in front of you. The experiment files can be found at pasco.com/free labs. If you search for Essential Physics Modular Circuits Kit under product title, you will get a whole bunch of labs that are related that could be done with the modular circuit set. And again, that has all of the student handouts there for free to download. We do have teacher keys and notes available. That's also with our PASCO portal. You can find some more information on the website about that. And thank you very much. That is our time for today. I hope you found this useful, and we will stick around for a few more minutes if you have any additional questions. Otherwise, feel free to leave the webinar and enjoy the rest of your day. Thank you very much.